Alright, let's take a look. This is number 9 now. We're just continuing with this Chapter 8 test. And let's see what they do. They tell you that this is a right triangle. They tell you this side is 8.3, 16 degrees, that angle, and you're solving for x. Okay, this is not one of our special triangles, is it? This is not 30, 60, 90. It's not any of those kind of things, 45, 45. But you have an angle and you have a side, and you're asked to find the other side. That's when you use what? What do we use here?
So, law of sines.
Not law of sines.
That's what I use my own.
You don't need to. It's a right triangle. Come on, let's everybody listen, okay? I got people looking all over the place. Let's pay attention. Okay, we don't have to use the law of sines on this, okay? We use the law of sines when we have a non-right triangle. Use the law of cosines when you have a non-right triangle. When you have a right triangle, the easiest way to do it, it's not the only way to do it, but the easiest way to do it is just your regular trig functions. What are your trig functions? Sine. Give me, come on, follow me. Sine, cosine, and tangent, okay? That's what you want to use. You use those when you have a right triangle. Don't go to the law of sines and the law of cosines when you have a right triangle, even though they could work. It's no reason to, because it's a lot easier, it's a lot simpler, shorter, just to use the trig functions when you have a right triangle. Is that understood? Some of you guys were using, I don't know, you guys in particular, I'm just thinking the test in general. I just remember when I was grading it that, like when we had, now you weren't here when we went over 1 through 8, but in the 1 through 8 we talked about 30, 60, 90. I had people trying to use trig functions on a 30, 60, 90 triangle. Don't use those. I mean, you can, and it can work, but it's a lot easier if you use the relationships that you know for a 30, 60, 90 triangle. Now, I was not picky on this test about how you wrote your answers. Remember I said earlier in the chapter that I was going to be, and you had to write it as a simplified radical if it came out to a radical and all that kind of stuff. I actually made it pretty easy for you, and if you just wrote it as a decimal, I gave you credit. Just because, I don't know, I felt bad. You went through the whole problem, you set it up right, and then you just, you know, you wrote it as a decimal or you didn't simplify the radical. And I thought, I don't want to take off that problem. You know, I don't want to mark that problem wrong just because you simplify the radical incorrectly. All right. So anyway, I felt a little bit bad about that, but I let you keep it as decimals. But on this one, this is definitely going to be a decimal. So here we go. So what are we going to use? We're going to use this angle right here. What is this side to this angle?
Adjacent.
It's adjacent. What is this side? Hypotenuse. Which trig function uses adjacent and hypotenuse? The cosine. So we take the cosine of the angle equals the adjacent over the hypotenuse. Okay? Now we have to get x by itself. So x is on the bottom. I don't want x on the bottom, so I'm actually going to put x over here on the top, on the other side. And then cosine of 16, I'm going to have to move it to the other side. It's already on the top. Where am I going to have to put it? On the bottom. Basically, I'm switching places with the x and the cosine of 16. So x is equal to 8.3 divided by the cosine of 16. I had several people put 8.3 times the cosine of 16. That's not the algebra. The algebra is you move the x over here like this. Do you see that? Canceled out. Then you divide by the cosine of 16, which means it would go on the bottom. So it's 8.3 divided by the cosine of 16. So let's punch this in and see what we get. Let's clear that. It's 8.3 divided by cosine of 16. Cosine of 16. And there you go, about 8.6. All right, so x is about 8.6. Again, I was not specific on this problem on how many places to round the decimals or anything like that. Actually, it did say that on several of these, didn't it? Okay, yeah, and it says round to the nearest tenth. Some of you guys took it 2 or 3 places. I don't know, some people might have even put a 9 right there. And again, contrary to the way my head tells me, my head says, if you don't round it to the nearest tenth, it's wrong because the instructions say to. So if I was a real tough math teacher, which I should be, I'm too wimpy, all right? I should be a lot tougher on you. And if you put 8.6, 3, then it's not rounded to the nearest tenth, is it? And I should take the problem, I should make it wrong, shouldn't I?
Yes.
Yes, I should. Okay, but I didn't. Just trying to help you out a little bit. I'm more concerned, look, that you can set this up and get this right there. That's what I'm concerned about. This is what I want to make sure that you know how to do. Whether or not you put it in a certain form, it's really not what I'm testing you on. I'm testing you on the fact that you can set up with a trig function and get this thing right here. Okay? All right, enough of that. Let's take a look at number 10. Okay, here's the picture. Oops. All right, let's go like this. Okay, watch carefully. It says an A-frame house. When they talk about an A-frame house, that means like, you know, here's the front door, right? You see that? Here's some windows, right? You get the idea? Isn't that crazy? That was a creepy house. That looks like a ghost house or something. Anyway, you get the idea. It's an A-frame house, which means... Let's get rid of all this mess. As you can see, I'll never be an artist. An A-frame house meaning, what do you think is true about these two sides right here? They're congruent to each other if it's an A-frame house, all right? And it says the height from the top to the bottom is 45, but I'm not going to draw it to the side like they do. I'm going to draw it right down the middle, all right? And it's that's the height of it. So the height is always perpendicular to the base, isn't it? So that thing right there is what? 45. Now, if it's an A-frame house, we kind of make a little bit of an assumption that those two are equal to each other, and they say that this angle is x and the whole bottom is 32. Alright, everybody with me so far? And it says find the measure of the angle that the roof makes with the floor. Well, this is the roof because an A-frame house, the roof actually comes all the way down to the ground like this. You ever seen any houses like that? They're kind of strange, but I've seen them. West Virginia, we go down this one road, and they've actually, I don't know, it must be the same builder or something. There's a whole bunch of houses that look like that. They're a little bit odd. You don't see them around here too much, but that's what it is. But they tell you right there, it's X, don't they? So they make it pretty simplified. I mean, you really don't even have to know much about A-frame houses and things like that, because they draw the picture for you already. And we just want to find this angle right here. Well, what do we know? If these two are equal, if it's an isosceles triangle and we drop a perpendicular down, what does it do to the base right here? Where does it hit? At the, give me a geometry word, at the midpoint. Okay, at the midpoint. So that would be 16 then, wouldn't it? Split 32 in half. So here's what we have. We just have a right triangle. We're trying to solve for this angle. We know this opposite side. We know the adjacent side. So which trig function uses opposite and adjacent? The tangent. The tangent of what? We don't know. X, right? So the tangent of x equals the opposite over the adjacent, which is 45 over 16, not 32. Some people put a 32 in here. It's a 16, right? Because it's this right triangle right here. And then you just solve for it. So watch. X is equal to the inverse tangent of 45 over 16. This is all calculator work right now. Let's move this over. And so second function tangent of 45 over 16. 45 divided by 16. And then there you go, 70.4. It says round to the nearest degree, so I wouldn't go 0.4, would I? It says round to the nearest degree, so x equals just 70 degrees. All right. Now, if you put 70 point, whatever I said that was, 70.4, I still gave it to you, but technically the question said to round it to the nearest degree. I should take off if you didn't do that, but I didn't. I'm trying to be nice to you. Isn't that nice of me?
Yes, sir.
Okay, that's what I thought. Just need to hear it. All right, here we go. Number 11. All right, here's some word problems. Now, these can be a little bit tricky, but remember what I told you. All these word problems are basically just right triangles, aren't they? So look at 11. It says a 38-foot tree cast a 16-foot shadow. I don't have to draw a big fancy tree. Some of you guys drew nice pretty trees, way prettier than I could draw them. But you don't really need a big fancy tree, do you? This vertical line right here represents the tree. And what does it say about it? 38-foot tree. So the length of that is 38. Cast a 16-foot shadow. Wow, I am way off base. So let's go like this. Is that better? Okay. So it cast a 16-foot shadow. So that would be right there. So let's find the measure of the angle of elevation of the sun to the nearest degree. Well, let's see what happens. Cast the shadow. So the sun's got to be up here, coming down like this. So this right here, okay, is the line, is the sun's rays are coming down like this if it casts a shadow like this. Is that understood? Does that make any sense? Okay. So, and what are we trying to find? The angle of elevation of the sun. So the angle of elevation is from the horizontal to that line of sight. This purple right here is the line of sight. So it's from here to here. So this is the angle that we're looking for. Okay, that's the angle of elevation. So look, you have a nice little right triangle right here, and then you just do some trig functions and solve for theta. It's the same one as we did in the last problem, isn't it?
Yes.
I got opposite and I got adjacent. So we got the tangent of theta is opposite over adjacent, 38 over 16. It's almost identical, it's just the numbers are a little bit different. So, again, just like we did over there, second function tangent, 38 over 16. 38 divided by 16. And you get about 67.1. And what does it say? Does it say to round to anything? Is this the tree one? It says round to the nearest degree, so what? 67 degrees. Alright, and that's theta. So that angle of elevation is 67 degrees. Just like that. Does that make sense? Tree, shadow, here's the line, the sun's coming down, and you just find the angle between that angle of elevation. So it's from the horizontal to that line of sight. That's the angle of elevation. We good? Alright. Let's move on. Alright, so we got a boat and a cliff problem here. So we have some water. So let's do this in blue. Make nice water. And you have a cliff. There's the cliff right there. Okay. Oops, what did I just do? Don't know. Alright, so let's see what we got. I'm not even going to attempt to draw a nice fancy boat. Some of you guys drew nice pretty boats, way better than I could ever draw, but I'm just going to say this point right here just represents the boat. You guys paying attention, right? Okay. So it says a boat is 2,000 meters from the cliff. So if I measure, if I'm in this boat floating along, floating along, right? Row, row, row your boat. And if I say I'm 2,000 meters from the cliff, how would you measure that? Would you measure it like this diagonal distance to the cliff? No, you would measure it from here, like horizontally, right? Yeah, straight across the ocean, right to the cliff. That's how you would measure that. So that's 2,000 meters. Oops. What did I just do? Turn this thing to that. Let's try this again. It was pretty cool looking, but it's not very good for drawing, or for writing. Okay, so 2,000 meters. It says the angle of depression, from the top of the cliff to the boat is 10 degrees. Okay, so if we go to the top, let's do this in a different color. The angle of elevation is always from the horizontal. So all I'm doing is just drawing a horizontal line there. All right, that just represents a horizontal line. The angle of depression is 10 degrees. That means from the horizontal down is 10 degrees. So that right there is 10 degrees. That's the angle of depression. But what do we know about the angle of depression and the angle of elevation? They're congruent. They're the same. So the angle of depression is 10 degrees. The angle of elevation is going to be the same thing, isn't it? And that's what we're more concerned about, isn't it? Is this angle right here. Some of you guys were making this angle in between here and here to 10 degrees. And that's not the angle of depression. The angle of depression is from the horizontal down to that line of sight. Does that make sense? This would be 80. And you could use this if you wanted to. You could put an 80 here and use the 80 if you wanted. All right. What else do they tell you? That's it, right? They want you to find what? How high the cliff is? Yep. How tall is the cliff? And so we'll just call it X. So look what we have. We've got a right triangle. I got a 10-degree angle. I've got this side is 2,000. I'm trying to find what this length is right here. So let's look at the sides. What is X to this 10 degrees? It's opposite. What is the 2,000 to the 10 degrees? Which trig function, for the third time in a row, uses opposite and adjacent? Yeah. Now you see why it's my favorite trig function, right? I love it.
My favorite is...
So the tangent of 10 degrees is opposite over adjacent. Now look at the math. Some of you guys, again, when I say you guys, you know what, I'm talking both classes because I can't remember who wrote what. But I remember a couple people really messing this up. Like taking the X and putting it on the bottom or the top over here. I don't know. Their algebra was real wacky. It's only one little step to this. It's not that hard at all. If I get X, it's already on the top, isn't it? I don't have to take it and move it to the other side. X is already in the numerator. All I got to do is get rid of the 2,000. How do I get rid of that 2,000? Multiply it by 2,000. That's right. So I multiply it by 2,000. And so let's put some stuff in here. So I've got 2,000 times the tangent, or I can just hit tangent on my calculator, 10 degrees. So 2,000 times the tangent of 10 degrees equals 352, and it says to round it how? To the nearest tenth. So what would that be? 0.7. 352.7. 352.7. That's how tall it is from here to here. That's what we just found. Make sense? Alright, I hope it does.
It does.
Let's keep going. Alright, this problem says a plane is flying at an altitude of 10,000 feet, begins descending when the end of the runway is 60,000 feet from a point on the ground directly below the plane. Wow, it's a lot of words, isn't it?
Yes.
And this is especially tough for the Koreans because it's hard enough for Americans to figure out what all those words mean, and when it's their second language, it's even more difficult. So they have to struggle with this even more than what you guys are struggling. So it says a plane. Let's just, I'm not going to draw a fancy plane. I'm just going to put this dot to represent the plane. All right, now what's it say? It says an altitude of 10,000 feet. So the altitude is what?
How high it is in here.
Yeah, but not just, give me a geometry word. We say this all the time with altitude, and I never hear it the first time. It's what? Come on. Perpendicular. It's perpendicular. Okay, we say this over and over and over again. I thought for sure you. I used to say it a lot when I was going over this kind of stuff. Well, anyway, it's perpendicular. Even if I didn't say it in a while, you know it's a right angle. It's perpendicular. That's the altitude. That's 10,000 feet. Right? Yep. And then it says, begins descending when the end of the runway is 60,000 feet from a point on the ground directly below the plane. So now, he's flying along real nice and pretty, and then, oh, he sees he's 60,000 feet from the bottom, from here to here. Okay, he's 60,000 feet, and he starts descending. All right, so that's 60,000 feet. So what are we going to draw? Draw a little. Okay, so that's the direction that the plane's going to be flying, right there. So he's flying along nice and pretty, nice and flat, and then he's like 60,000 feet from directly below where that plane is. He sees the runway, all right, and he starts descending. So now he's on his descent flight path, whatever you want to call that. All right, so what are we trying to find? It says find the measure of the angle of descent or depression to the nearest degree. Now watch, you could draw the horizontal out just like we did with that boat problem, right? And say, okay, this is the angle right here. But remember, the angle of depression is the same thing as the angle of what? Elevation. So instead of going through all that up here, we realize that, and we can just do what? Figure out what this angle is right there. That's the angle of elevation. So that's what we're looking for. Okay, we're trying to find this angle right here. Does that make sense? Okay. So now, wow, look at this. Our favorite. So the tangent is equal to what? Opposite over adjacent. 10,000 over 60,000. Look, I can just get rid of actually 4 of them, right? I could just put 1/6 in my calculator, couldn't I? Yeah. Instead of all the zeros. It wouldn't make any difference. So let's just go ahead and do that. Let's go second function, right? I'll turn it on first. Okay, so let's go second function tangent. Where am I? Right there. Of what? 1/6, right? You understand why I put 1/6? I mean, you could put all those zeros in, but what if you know, there's so many zeros, what if you messed up? What's that? Yeah, well. Yeah, divided by. Don't do fraction. Yeah. I've never used those fraction things on there, okay? When it says over, it means divide. So put divide, okay? So anyway, there you go. So 9 point, what does it say to round it to? Nearest degree. So it's 0.4, so what does that round to? 9 degrees. So that angle of elevation is 9 degrees. Now some people put 10 degrees. And what I had to do is I had to go back and look at your math to make sure you set it up right. Because 9.46, I can kind of see where you're thinking. You're probably thinking, oh, the 6 rounds the 4 up to a 5, and the 5 would round the 9 up to a 10. Look, again, I was way too easy on you on that one. I actually gave a couple people 10 degrees on this. But I made sure I went back and I looked to see if you set it up correctly, though. All right? And if you did, and you just rounded it to 10, I still gave it to you. All right? But technically, that's really not rounded to the nearest degree, is 10. It should be 9. All right, enough of that. Which one was that? That was 13, wasn't it? All right, so let's go to 14. All right, this is number 14. Now look at this. Can we just use the regular trig functions on this one? Why not? It's not a right triangle. Yeah. Okay, well, just for fun, let's find this angle right here. What do you think that would be? 68. What would we do? Just 180, right? Minus 68 minus 42. Just to make, okay, it's 70 degrees. I just wanted to double check just to make sure that didn't come out to be 90. Okay, is that all right? So it is 70 degrees. So I do not have a right triangle right here. So I got to figure out another way to solve for x. Well, what do you think? I like this. I would use law of sines on this. Would you? I kind of like the law of sines on this one because watch. Here's a side. I know the angle opposite that side. And here's a side. I know the angle opposite that side. All right. Does that make sense? So let's let's do that. Law of sines. I like to set it up like this. I don't know why. X over sine of 70, and then what? 23 over the sine of 42. You could cross multiply, but look, x is already on the top, so really one little step. All you got to do is do what? Get rid of this thing that's being divided. How do you get rid of something that's being divided? You multiply. So really, I just multiply by the sine of 70. See that? That goes. X equals. Plug all that stuff in your calculator. Let's see what that looks like. So it's 23 sine of 70 divided by sine of 42. 32.3. What's it say to round it to? To the nearest tenth. Is that right? Yep. Oops, that's an ugly 3. 32.3. Okay, and there it is. That's all there is to it. Just using the law of sines. Be okay with that? Law of sines? Alright. Let's move on. Well, let's take a look. Let's see what they give you and see which way we want to use. Do we want to go law of sines or do we want to go law of cosines? Well, look what we're trying to solve. Solve for this, right? We know the side that's opposite that angle. Okay? And we also know, watch, this angle and the side that's opposite this angle right here. So really, law of cosines would be pretty tough. In fact, I don't even know if you could use a law of cosines. Yeah, I don't even know if you could use a law of cosines. I would use law of sines on this, wouldn't you? Alright, so watch. Let's do it again. Let's go. If you wanted to, watch, I'm going to switch the order. I've always put the side on top and the sine on the bottom, right? The sine of the angle on the bottom. But since x is what we're solving for, let's put that on the top, right? We could switch them. Doesn't make any difference. So sine of x over what? Sine of x over what? 6, right? Okay, because they're opposite each other. Okay, equals. Let's go. We got to put the sine on top of this one too. Sine of what? 38 over what? 17. Everybody see that? That's supposed to be sine right there. It looks kind of weird. Now watch what we're going to do. We're going to multiply both sides by 6, right, to get rid of this. And then I want to get x by itself, so what am I going to do to get x by itself? Take the inverse sine, right, of all this stuff right here. Let's just write it all out. Okay, so that's all the stuff that you're putting in your calculator. So let's go ahead and do that. You know what I'm going to do? Just so I don't know. I like to just do this stuff first and then take that answer and then take the inverse sine of it. To me, it's just a little easier. I don't know. So 6 sine of 38 divided by 17. Okay, get an answer for that. Now, watch what I'm going to do, though. I'm going to take the inverse sine of this answer right here. How do I do that? Well, I take inverse sine of what? The answer. How do I get answer on this calculator? Second, this thing right there. See what I did? So whatever the answer before this, that's what goes right here. So I'm taking the inverse sine of all this stuff right here. It equals, and there you go. And this says to round it to the nearest degree. So what would that be as the nearest degree? 12.5 rounded to the nearest degree would be 13, right? So x is 13 degrees. Well, look, just to help me out a little bit, circle your answers when you're done. If you have a whole bunch of work, don't just kind of hide your answer in the middle of all that work, right? Make sure that you circle it, and And if it's an angle, put degrees. I don't mark off if it is, but I tell you what, I do know that there are teachers out there that if you don't put degrees, they're going to mark it off. I promise you, I've had them. Right? If you don't put the units like feet or meters or inches or whatever, they'll mark the problem wrong, even though you did everything correct. I think that's a little bit silly. But actually in physics, when I taught physics, I would mark problems wrong. At least I'd take off partial credit if they missed the units, and they didn't have feet or inches and stuff like that. So yeah, in the sciences, that's pretty important because it's a big difference. If my answer is 5, that's a lot different than 5 feet's a lot different than 5 yards, isn't it? Then it's different than 5 miles. So units are very important when it comes to that stuff. All right, let's do number 16. All right, here's number 16. Let's take a look at this. Let's drop it down a little bit. There we go. Now, are we going to use law of signs on this one? Even if we wanted to, we couldn't, could we? Because I don't know any of the angles. I got to know at least one of the angles in order to use the law of sines. So I'm going to have to go law of cosines on this, and that's fine. Because look, here's the angle I'm going to use. I know the side opposite, and I know the other two sides. So that's perfect for me. So let's do the law of cosines. So what is it? C squared, right? Or in this case, what is it?
X squared.
How about 8 squared? Because we're taking the cosine of x, right? So at the very end, remember the cosine of c? Remember that as far as our formula goes? We're going to cosine of c. But we have to go 8 squared first. Equals, starts off just like Pythagorean theorem. So it's always the side opposite the angle that we either know or we're trying to find out. Equals what? 9 squared plus 16 squared minus 2 times AB, or these two right here, put a 9 and a 16 right here, times the cosine of the angle that's opposite side 8, which is, what is that? It's x, isn't it? X degrees. So there you go. That's setting it up. All you got to do now is a couple little algebra steps. And they're really not that hard. I'm going to wait and put it all in my calculator all at the end. Okay, I'm not going to go through these individually and write down 8 squared is 64, 9 squared is 81, 16 squared is whatever that is. Okay, I'm not going to do that. I'm just going to write it like this. 8 squared. How do I get rid of this 9 squared right here? I subtract it. So I subtract it. How do I get rid of this plus 16 squared? I subtract it. Everybody see that? Look at this. Look at the negative 2, the 9, the 16. They're all being multiplied by the cosine of x. How do I get rid of stuff that's being multiplied? I divide. So I divide all this stuff. I know it's going to cancel out. I don't have to show the division over here. But I know it's going to divide. So it's negative 2, 9, 16. Right? So I divided that, that, and that. And that all equals what? The cosine of x. Now, at the very end, I'll chuck this all in my calculator. At the very end, what am I going to do?
Multiply by inverse.
Well, not multiply, but I'm going to take the inverse cosine of this thing right here. Alright? So now it's just calculator work, isn't it? So here we go. Let's do it. 8 squared minus 9 squared minus 16 squared. Okay? Divided by. Now watch. I'm going to put a big old parentheses right here. In fact, remember doing this? Put a parentheses right here, and then put a parentheses right here. I'll make that a little thicker. Okay, that's one big parentheses. Alright. So what do? Put a parentheses first, right? And then put negative 2 times 9 times 16. Okay. Close that. Alright, that's this parentheses right here. Let's see. Yep. I just hit equals now, right? Pretty sure. Actually, I probably should have put parentheses around that first group right there. No, I don't think I need another one because I only have one here and I got one here. I think this will work. We'll see. Alright, and then do what? Second function cosine, right? Second function cosine of your answer. We already talked about that. Let's see what we get. I knew it. I know what I have to do. Watch. Let's try this again. What I need to do, see what it's doing? It's going 8 squared minus 9 squared minus, and then what it's doing is this. It's going 16 squared divided by all this stuff. Do I just want 16 squared divided by all this? No, I want this whole thing up here. So I wonder if I can't get back to it, can I? No. Watch. So what I'm going to do is this. I'm going to go 8 squared
All middle school
in parentheses minus 9 squared
go to your homeroom to get your
minus
new
16
and then report to your 8th
squared.
period class.
Close that parentheses, then hit divide, and then do what we did before. Let's see if that works. Negative 2 times 9 times 16. Close that parentheses. I think we're good, right? Hit equals. Yep. Now hit
Middle school
second
girls
function
Bible
cosine
study, please meet in
of the
community
answer.
lobby. Middle school girls
Close
Bible
that.
study, please meet in
And
the
voila,
community
there it is. Yay, we got
lobby.
it.
Bring your book.
Okay. It says round to the nearest degree, so what would it be? It'd be 19, wouldn't it? Okay, so equals 19 degrees. All right, I'm going to finish this up tonight sometime. All right, and so I'll have 3 different YouTube things on here for this test. So watch them, be ready to retake this on Monday.